Alright, last class of Unit 3, we're going to go ahead and look at the combination of different transformations, and I have a little bit of work for you to do. So let's just start right away. So in the past few classes, we've talked about horizontal translations, horizontal stretches and compressions, vertical translations, vertical stretch and compresses. So first we're going to start with reflection, combining reflection and stretches. So -3 f of x. I don't need you to draw me the graph because obviously I have the graph. So you should follow this on your textbook, but really I can give you it. But let's go ahead and see what we can do here. So we're gonna go ahead and just name the transformation. I don't need you to draw it. I just want you to name the transformation. So you're gonna tell me it's reflected. So you have to go ahead and, for example, I'm gonna go get a text box, but on the test, you're supposed to write reflected about the y-axis, and then you're also gonna write, well, the x-axis, sorry, because that's the y transformation, x-axis, and then you're gonna also write vertically stretched by a factor of 3, right? That's what you're gonna write for the part A one. For A, this is -3 f of x, right? This is reflected and then vertically stretched. And then for 1 over 2, -1 over 2 f of x, I want you to go ahead and write reflected about the x-axis as well. And then you're going to be like vertically compressed by a factor of 1/2. Right? So this is how you're gonna answer a question like this. You're gonna answer you're gonna tell me the transformations and blah blah blah. Because I believe everybody should be able to graph. If I give you some dots and you can't graph it, you should go back to grade 8, by the way. You should be able to graph this with absolutely no problem. So let's move on to some real stuff. Let's move on to question number 2, where we're actually talking about transformations. So again, I want you to go ahead and tell me what's happening to this. Like, give me some transformations, man. Like, tell me what are we doing here? Like, give me the transformations. So you will go ahead and be like, okay, first, we are having a vertically compressed by a factor of 1/2, right? That's simple. We tell from this. And then we're looking at it and be like, oh, look, there is no horizontal translations. So that's good. So now we're going to name the other one. Vertically translated 5 units downwards, right? Because there's a -5. And then finally, we get to +3. +3, because x's were weird, we actually move 4 left, right? So 4 units, so we will write 4 units to the left, uh, horizontal translation 4 units to the left. And that is how we're gonna write everything. Basically, this is how we sum up. This is how we sum it up. That's what we're gonna do, and that's pretty much it. Because I believe if you have the original function, you should be able to absolutely draw this out. This should be no problem. And again, I also want you to actually give me the mapping rules. So mapping rules. So what are you doing to x? So in this case, x becomes what is this? I believe this is x becomes x minus 4, right? So we're moving 4 units to the left. So that's pretty simple, no questions. And then now we have to do the y transformations. So let's see, what do we do to y? So we're gonna look at it and be like, oh, wait a minute, look, we have 2 things that we're doing to y. So y is gonna become 1/2 y minus 5. Minus 5, right? So this is our mapping rule. And we're going to use this mapping rule. So for example, originally my point was 0, 0. I'm going to use this mapping rule to become 0 minus 4. Okay, so -4, and then 0, 1/2 times 0, which is 0, minus 5. So 0, 5 is now my new vertex, right? So we can use this. And obviously, I'm going to go ahead and grab the graph from the textbook for you guys. So let's just get the text. Let me just get the graph. Okay, so here is a graph. So they actually did a step by step. They did the 1 over 2x first, and then they did this. So you can see here our vertex is -4 and -5, which follows our rule. And then we look at it and be like, yeah, that's pretty much it. All I need you to do is to be able to describe me the transformation. I believe everybody can graph it. No worries. Now we're gonna do it to a radical function. So, people think radical is a little harder. Really? It's a little arguable. I wouldn't say it's a lot harder, but many people hold different opinions. So I do not know, and I do not care. So let's go ahead and look at it. So first, we're gonna go ahead and clear this. So let's see. A while back, I told you the general form. So the general formula, right? So it was y equal. Oh, I shouldn't write this big. I should write much cleaner. Y equals a f k x minus p plus q. Right? And you can look at it and be like, hey, wait a minute, we can use all of this now. Whoa, that's so cool. We can use all of this? That's so cool. So, right, we're going to use all of this. So, first, since we used f of x in the general formula, why don't we plug in the square root function first? So, essentially, we're going to have y equals 2 square root of negative x minus 3 plus 4. And now you might notice something different. Hey, wait a minute, my k value isn't apparent. But look at my x. Originally in my x, there is no negative sign. So in our general formula, the x is completely by itself. There is no coefficient of x. There's nothing of x. So whenever we have something like this, we're always supposed to factor it. So we're supposed to do this. And this is how the function actually works. If you do anything other than this, you're wrong. You're wrong. So now with our fully graphed, well, with our function, we wrote out all of our transformations. Let's describe it. Vertically stretched by a factor of 2, right? No problem. And then now let's see. What else? We look at it vertically translated to 4 units up, right? No problem. And then let's look at it. There's an X transformation. So look, K is only negative, and there is no actual value. It's just a negative mark. What does this mean? This means we're flipping it across the y-axis. Flipped about the y-axis. And finally, we have horizontally translated 3 units to the left because of plus 3, right? So usually some teachers want you to give out the flipping first, but in my opinion, I don't think it really matters because you're not you're gonna apply all of them anyways. It's not like you're gonna apply only one and stuff like that. No, that's not how it works. So that's pretty simple. That's that. Let's go ahead and do some other stuff. Let's go ahead and write out the mapping rules, I guess. So we look at it. So for the x right away, we're dividing it by -1. So x divided by -1, just negative x. So x is going to become negative x, and then we're doing 3 units to the left, minus 3. Right? Simple. And then y is going to become 2y plus 4. Very simple. This is our mapping rules, and that's pretty much it. And let's move on to another horizontal stretching and reflecting one. So this one actually wants us to compare it. And so we're gonna compare it. Why not? So we're gonna compare it. So for our original y equals x, y equals square root of x, it's supposed to face rightwards, if you know what I mean. So here's our graphs. I'm gonna give you that. So y equals square root x is the only one that was not flipped around the y-axis, right? So the rest, we can notice one common thing is that all of them are flipped about the y-axis, right? All of these are flipped about the y-axis, right? And then we can see there's different degrees of horizontal compressions or stretches done to these. So we can see there's a horizontal stretch by a factor of 2, horizontal compressed by a factor of -1/2, and it's one of them, which is y equals negative square root of x. That's just flipping across the y-axis, right? So all of these should be pretty simple. We did this, and then let's just move on. Now this is the hard part. So they're gonna describe us the function, and we're gonna have to write out the equation. So I usually write out the general equation first because I like the fact that I'm filling it in. I like the idea of doing that. So and many times when I fill it in, I'm like, okay, I'm not missing anything. I'm good. I factored my x's. I'm good. So let's see. This is expanded vertically by a factor of 5. So a equals 5 right away. Reflected by the x-axis. So whenever we're reflected by the x-axis, that means a is a negative value, right? We're flipping. If we're flipping about the y, it will be the k value. But if we're flipping about the x, that's the a value, right? Simple. So a is a negative value. Translated 6 units to the right. Right. So that would be p would be 6 because x minus 6, that's actually 3 units to the right. And then 3 units downward, so q equals negative 3. So finally, we'll go ahead and fill it in. All right, let me expand that. So y equals negative 5. Um, k is, there's no k values. Wow, unfortunate. X minus 6. And then, oh, okay, I can just do this. X minus 6 plus minus 3, right? So therefore, that's our function. And you just have to add the square root here. So I just add the square root. Square. So the square root only covers this part. So that's basically our function. And we should have something that looks sloping downward, that looks a little funny. I'm going to give you the solution right here. So this is our solution right here. This yellow one, it looks a little funny. It's going downwards and it moves very steep. So that is our function. Finally, we're going to go ahead and describe our one last quadratic. Let's do that. So let's see what is done to this. What is being done to this? Look at it, and we're like, okay, let's see. Right away, we're telling you flipped about the x-axis. Why? Because there's a negative of that f, right? And then we're gonna see what else. What else is going on? So let's see. There's 2. However, remember, you're doing x divided by 2. Since this is the k value, you're doing x divided by 2 instead of 2x, right? So x divided by 2. So what is x divided by 2? Whenever it's between or less than 1, that's a compression, right? So horizontally compressed by a factor of 1/2, right? Pretty simple, right? There should be no problem with this. And then we're going to be like, horizontally translated 5 units to the right because it's negative 5. So that's actually 5 units to the right. And then finally we have 6 vertically translated 6 units upwards. So basically, whenever you describe something, I want you to describe horizontal or vertically, compressed, or are you translating or are you moving by a factor of what? Or you can just say 5 units up, right, down, left, or whatever. And that's pretty much it. I don't believe you have any problems. So let's, you know what, we'll just do the mapping rules, even though that's not, I don't require it. So mapping rules. X will become, we are dividing by 2. So x over 2, that's definitely true. And then plus 5, right? Because we're moving 5 units to the right. And then this will have, we are doing negative y since we flipped it across the x-axis. And then we're moving 6 units up. So 6. Simple. That's that. And that is our mapping. So there's not much to do for this class, really. Because it's just applying what we learned already. But I want to take this moment to kind of talk to you about decimals. So schools were not sponsored by decimals at all. We're never okay. We never take sponsors from a specific app and be like, use it. Decimals is a free app. It's gonna help you to graph everything. So right here we have these. Sometimes teachers will give you like a literal decimals test, so you can use decimals to graph and solve stuff. So I want you guys go ahead and try these out because these ones are really fun. Do these, and then I also want you guys to describe it. I don't want you guys to do that much sketching. Even for sketching ones, even for those that ask you to sketch, I want you guys to practice more on the domain and range. I want you guys to learn how do I describe a domain? How do I describe the range? And I want you guys to describe the transformations. I don't care if you guys know how to draw it or not. In fact, I believe if you just know the dots, you'll be able to know how to draw it. I care more about you understanding what's happening to the function. And essentially, that is what I care about because that is what's the name of the course, functions. So, anyways, that is the end of this lesson. If you have any questions, reach out to me however you want, and that's it.